Welcome to AIQ, Applied Intelligence. At AIQ we are a blend of decades of experience at utility level and design and production of protection related equipment. Some fault passage indicators will identify the faulted section, but we do need to get to the actual and precise location of the fault so that it can be repaired, preferably with decent earth fault sensitivity. 10 kiloohms would be very nice indeed. Utilities operate with a multitude of different neutral treatments, so clearly such location is required with all of those neutral treatment types. With compensated neutral systems, for example, the fault may remain energized. It may be tripped after some seconds or minutes, or it may be tripped immediately. In all of those cases, precise fault location is still required. And generally speaking, it would be nice to have that either handheld or drone operated. So how does the AIQ device do this? Essentially, we have three detection modes. One is looking at the magnetic field associated with the earth fault current in the overhead line. Second one is looking at the change in magnetic field in response to some change on the power system. And the third one involves the introduction of a tracer signal. Section has been identified, then the really hard work begins. Typically the operator will use a binary search method and successively split the known faulted area into ever smaller sections, basically by halving the faulted section each time, hence the term binary search. So the operator will navigate all the way to the particular fault location, whether that be a faulted surge arrest or down conductor, whatever it might happen to be. This unit can work with the fault energized, for example on compensated neutral systems, or if the fault is tripped, it can then be re-energized in order to take a measurement. And the unit will also work with the line out of service. So the first of the three modes is the pure magnetic field measuring, and in that case there is an estimate of the earth fault current displayed, as well as whether the fault is forward or reverse of the measuring location. In regards to the change in magnetic field measuring, that's typically achieved by altering either the damping on the system, injecting extra capacitance for example, or maybe changing the position of an arc suppression coil. With the tracer signal approach, that's initiated by injecting a high voltage surge. More closely just at the injected signal approach. As we said, a pulse is injected and then measured at the start of the feeder. That's for reference purposes. Then that binary search approach that I mentioned begins, and each subsequent measurement taken is then compared with the original reference, which was known to be in the fault path. And as you can see by looking at the two diagrams below, in the case of the forward fault, the measuring position and the reference position are very similar indeed. Whereas if the fault is behind the measuring position, then you can see there's a very significant difference between the reference and the measuring point. So there's a very clear indication whether it's forward or reverse. The unit of course just indicates in language terms, and the software behind it can display these waveforms for future reference. That's it for this little presentation. Any questions, please feel free to contact me.